divided by steel because we make the reference material steel. Okay, so this is equal to 1, right? Nothing changed, right? Now we have the N of brass, right? So this is E of brass divided by E of steel, and E of brass is about 100. Okay, gigapascal. This is 200 approximately. So we know that this is like half. Okay, we know this. So what does this actually means? Okay, so this is where it's important. So I'm going to draw out to you what does this actually means. Okay, so the top and bottom layer is still our steel. Okay. Right. So now the center portion where you see brass is going to replace by steel. Now, question for you: if the center portion is made of steel, right? Will the structure look like an eye or look like a hamburger? So if we replace everything look like steel, does the structure now looks like this? Okay, looks like this, or looks like this? That's why I call eye or a hamburger. I'm hungry. Right? Where you have two pieces of bun, the center is the meat. So which one is it? If we were to replace the center part with steel, anyone, please.
Is it I?
Absolutely. Right? Because it's twice as young. So what we actually did is it will replace like an eye. Okay? Replace an eye. So this is brass is made, right? Brass is made equivalent to steel. So you don't need so much material, yes or no? Right? Because the Young's modulus of steel is twice of brass, so it's half its size. Okay. Now, what you all can realize? Can someone tell me what changes? So if this is declared as our width, right, parallel to the axis of interest, and perpendicular to the axis of interest, this is our depth. Now, question for you: what changes? Anyone? What did we change and what did we held constant? I repeat again. So what did we held constant and what did we change? Anyone in terms of geometry? Hello? Anyone, please?
The width changes and depth remains same.
Yep, you're absolutely right. Now, Lux or anyone, do you know why? Why height is held constant, right? We change to make it equivalent to the brass to become steel, but our height, right? Our height is held constant, right? You can see down here, the brass, the number of squares is 1, 2, 3. Yes or no? The number of squares we use is also 1, 2, 3, right? We did not change the height, but we changed the width. Any idea why? Anyone, please?
If we change the height, it would throw off the second moment of area by too much.
Ah, very, very good. Now, Jinder, how come you know?
I don't know. I just thought about it.
Huh?
I just thought about it.
Yeah, you are absolutely right, Rajinder. Wow. So this is because of the second moment of area. This is because it's to simplify. Okay, simplify simplify long spelling. Come on, Eugene, wake up. Simplify. Okay, the second moment of area analysis. So what do we mean by that, right? So if we look at the second moment of area, okay, so we look at IZZ. So this is width multiplied by d cube divided by 12, right? Plus by the width multiplied by depth, right? Then we have the centroid, the global centroid multiplied by the individual centroid squared. Okay. Now, if the n, if we change n, if we change the height, right? If we change the height, this will become what? N d what? Cube. Okay. So i.e. the coefficient also become n cube d cube, which is wrong. Okay, it makes the analysis too complex. So the n, the coefficient, belongs to the width. Changing the width is fine because there is no power term. Yes or no? So I'm going to write this for sandwich material. Okay, for sandwich material is IZZ is equal to, so the n belongs to the what? To the width. The depth did not change at all. Okay, plus by the n width multiplied by depth. Okay. And it's for this reason, right? You can see that, yes or no? Right? It's for this reason the width, right? The width changes only. Width changes. Right? And then the depth is held constant. Okay. Now, it does not matter what material you choose. Okay. You just need to pick something. Okay. So in the next one, case number 2. Okay, case number 2. Is we have brass is the reference material. Oh, I do apologize. You all have any question regarding this? Does that make sense? Yes or no? You don't have any question with this? Is this point, right? Is the n cube over here, right? Which we try to avoid. Okay. Anyone, any question? Rajinder, you got that right. Is purely because of the second moment of area. Okay, purely because of that. Okay. So I don't hear anything. So what if now, right? We were to change now. Okay. So brass is made of the reference material. So N of steel is equal to E of steel divided by Young's modulus of brass, right? So this is 200 over 100 is equal to 2. And then the N of brass is equal to E of brass divided by Young's modulus of brass again. We know this is 1. So now brass did not change. Okay, so the width of the brass and the height did not change. We know that it's the same. right? So it's the same. So we drew at as 4. Okay, so the original one is 4. Okay, so this is our brass. So now we replace the steel at the top and the bottom with brass, right? So now what is going to happen is now the geometry changes. Right? It still looks like an eye, don't get me wrong, right? But in perspective, now the brass for the top and bottom, the width increases, yes or no? Right? So this is the steel, right? It's make equivalent to brass. Okay, right? So now you understand this now, right? So that's why we only change the the width, the thickness, or the depth still remains as constant. Okay, now if we were to now, right? So let's say now, what if the moment is applied in the y-axis? What happened? Okay, so I'm going to copy this whole diagram. Okay, I'm going to copy this whole diagram. And paste, and I'm going to modify this diagram slightly. Okay, we're going to modify this diagram slightly. Okay, so we're going to modify this diagram. Now, I'm not Eugene, come on. Okay, so still the same. Now, the moment is applied, right? The moment is applied about the y-axis, right? So the axis of interest is going to be I what? YY, right? So IYY, I'm going to draw orange line. This is our IYY now. All right, these are IYY. So parallel to the axis, this is the width. Perpendicular to the axis, this is the what? This is the depth. Okay. So now again, we use the same scenario. Okay, we use the same scenario that case 1, steel is the reference material. Yes or no? Right. So if steel is the reference material, if the center is replaced by steel, how does it look like? Okay, so it looks like this. So now the depth did not change. I repeat again, the depth is still the same. Come on. The depth is still the same. Right? So wrong color. Come on. So the depth is still the same. But the thickness now what? Changes. Okay. So the center part, which is brass, is now changed to steel. So now the structure look like this. So it used to be 3 squares. Width now becomes 1.5. And then you have a 1 down here. And then you just compress everything. Okay. So this is your steel. And the center is a brass equivalent to steel. Right? If you replace the center part with steel, right, the width changes. So now, because the moment is about the y-axis, right? So we're interested in y axis. So this is our width, and then this is our depth. Our depth did not change. So the last one, what if the last one, case number, like what we had before, where brass is the reference material. So if brass is the reference material, right, the brass did not change. So the brass is what did I draw the brass? sorry, the brass is what 4 by 3. Okay, so the brass did not change.